The lesson topic for this video is radical functions, L1s and L3s. And what I mean by that is these are going to be examples in this lesson about what the level 1 questions will look like for this assessment and what the level 3 questions will look like. So, first of all, you will be expected in the level 1 questions to be able to graph accurately a square root function and a cube root function and accurately tell their domain and range. So that's what we're going to do in the first 2 slides is we'll do one square root example and one cube root example. If you would like to pause this video, try it on your own, and then check to make sure that you have it done correctly, that would be fine. If you feel like you need to watch again to see how this goes, that is fine as well. Do what you need to do. Okay, so one of the most common errors that is made with this type of example is the fact that the 3 and the x inside the square root are in the order that they are currently in this example. I have suggested and I continue to recommend that you use a rewriting process in order to accurately graph and tell the domain and range for this function. Typically what I see on an assessment when people get these wrong is because they do not physically rewrite them. So I highly recommend it. Alright, so we're going to rewrite this equation y equals 2 times the square root of, and now we're going to switch the 3 and the x around, but remember the signs have to stick with them. So the x is negative, so negative x plus 3, and then the minus 4 stays out here. Okay, now once again, we need to rewrite this equation so that the negative is factored out. That has to be done in order to use the shortcut graphing method that I have taught. So we're going to rewrite this again, y equals 2 times the square root of negative, factoring that out, makes the x positive, but then the positive 3, if I factor out a negative, I need to make that a negative 3. Okay, and again, think about distributing this negative back in to make sure that you get back to what you started with, and then minus 4. That doesn't change. So now we need to be able to write down our starting point or inflection point, depending on the type of function we are doing. Notice this is a square root function. There's no 3 right here. In a square root function, therefore, this is a starting point that we will write down. The starting point is 3, negative 4. Okay? Since this is a negative 3, it goes into our point as a positive 3, and this negative 4 goes in as negative 4. And then how are we going to have this graph curve? Because this is positive 2, it is going to curve up. And because this is a negative right here, it is going to curve left. So up and left from 3, negative 4. Alright, so 3, negative 4 is right here. And it needs to curve up and to the left. Up and to the left, half of a parabola on its side. It should look like that. Now, like I mentioned, we also will need to be able to write our domain and our range for this function. Remember that domain is leftmost to rightmost, and range is bottommost to topmost. So when we think about our domain, leftmost comes first. Now this curve is pointing to the left. Okay, if it's pointing to the left, that means it's going infinitely to the left, which is a negative infinity. Okay, the rightmost point for this curve, well, if we think about heading to the right, we stop right here. That's the rightmost point. And that rightmost point on the x-axis is 3. Remember, we put a bracket on the end of this one, not a parenthesis, because it is a specific point. All right, now the range. The range we need to go bottommost to topmost. Again, if you think about this curve, if you just kind of trace it back and forth, like where's the bottom of this curve? Well, the bottom would be here at this point, and that lowest point is at negative 4. So we have negative 4 with a bracket right here. That is the lowest point on the curve. And then since it is curving up, infinitely up, we know that the uppermost point is not a point specifically, but infinity. And that will use a parenthesis. Okay, so the second example here is an example of a cube root function, and again we need to do those same steps as we did in the previous example. Before we get started, we want to factor out this negative. We want to rewrite it. So y equals -2, that stays the same, times the cube root of, and I'm going to factor out that negative, the x becomes positive, the 1 also becomes positive because we factored out the negative, and then plus, oops, sorry, that's a plus sign, plus 5. Okay, now we are able to find our point, and this time it's an inflection point because this is a cube root function. And we're going to use our -1 and 5 for our inflection point. The opposite of +1 is -1, and 5 goes here. Now we have to determine how this curves. Remember that since this is a negative here and this is a negative here, the signs match. And when the signs match, this is going to be an increasing function. Okay? So again, we don't say down and left. That's not how this one works because it's a cube root situation, but it's an increasing function. All right, so let's put that point -1, 5 right here. And then an increasing function is going to curve up and to the right and down and to the left. Okay, and I'm a little off there, but that's okay. So it should curve right through there. Okay, so there is our curve increasing from left to right, and again, both sides look like a half of a parabola lying on its side. Okay, and now we are going to write our domain and range. Now, if you remember from the previous lessons, the domain and range for a cube root function are very easy, because if it is leftmost to rightmost, well, left it's going forever, and right it's going forever, and ranged bottommost to topmost, it's going down forever, and it's going up forever. So the domain and range are both -infinity to infinity. And there we go. Okay, now what we're going to talk about on this screen is some examples of what a level 3 question might look like on a test. So what happens in these examples is that instead of giving you the equation and asking you to graph it, I give you some information and ask you to draw a relevant graph for that situation, for that information. So, in this first example, we'll call this number 1, the graph starts at 3, -2. The domain is 3 to infinity, and the range is -infinity to -2. So, first thing I would do to create this graph is put my point on there, 3, -2, which is right here. And since it says it starts there, it doesn't say it's inflecting there, it's starting there, we know it's a square root function. We also know it's a square root function and not a cube root function because if it was cube root, these would all be infinity and -infinity. Okay, so now if the domain, the x values, is going leftmost at 3 and rightmost towards infinity, we know that it is going to curve right. Okay, so this tells us here, since leftmost to rightmost is going towards infinity on the right, it's going right infinitely. The range, on the other hand, tells us it's going from -infinity to -2. So bottommost, it's going infinitely down, and then the topmost is -2. So we know that this is going down, right? Because this is going towards -infinity. So we need, from that point, for the curve to go right and down. So right and down would be this curve right here. Okay, if you wanted to double check that the domain and range fit this graph, you can. So it goes from 3 to infinity. Yep, it's starting at 3 on the x-axis as it's going infinitely to the right. And for the range, is it starting at -infinity, meaning is it going down? Yes. And then what is the uppermost? Again, bottommost to topmost. The topmost point is at -2. Now number 2 says the graph has an inflection point at -2, 1. So -2, +1 would be right here. And since we know it's an inflection point, we know it's a cube root function. And it also says that it's decreasing. All right, so if it's decreasing, I can't go up and to the right. I'm going to have to go up and to the left. And then we're going to go down and to the right. So that is a decreasing function with the inflection point at -2, 1. So here are two more examples like that. Why don't you go ahead and give them a try and check back to see how you did. Okay, and here are the two graphs you should have come up with. Let me know in class if you have any questions.